Okay, ladies and gentlemen, welcome to Arithmetic Sequences. If this is your first time working on this, welcome. So, arithmetic sequences just has to do with how we look at things. For example, if we had the numbers 2, okay, that did not work out well, let's try that one again. If we had the numbers 2, 4, 6, 8, 10, and it kept going, they're asking what the pattern is. Now, sometimes they tell you, though, that, for example, this is the first term. And then this would be the second term, this would be the third term, etc., etc. Now, there are some really cool ways to find it. There's something called the recursive, and there's something called the explicit. Let's look at the recursive formula first. So recursive, and the way that I like to write this is a with a little n equals a, and I call this sub, so it's n minus 1 plus the difference, or minus the difference, and then you just have to state what your first term is. And this is how the recursive formula works. So for example, for this one, since to get from 2 to 4 we're adding 2, and from 4 to 6 we're adding 2, so it has a common difference because it keeps going with the same one. It would be a sub n equals a sub n minus 1 plus 2, because that's our difference, and then the first term, which is 2. Yay, we're done. That's all you have to do for that. And what it's supposed to do is that we could find out what the 7th term is by using the 6th term. And believe you me, I completely agree with what you're thinking. We have something else called the explicit formula. Now, the explicit formula, I think, is a little bit more useful just because you can find any term using this. So the explicit formula is a sub n, which is, and then it's whatever the first term is, plus their difference, times the quantity n minus 1. Now, in this case, since it's our first term is 2 and it's our common difference is 2, so it'd be a sub n equals 2 plus 2 times n minus 1. So you can write it like that, but a lot of times what will happen is you'll see that 2 distributed. You'll see this 2 distributed, and so then something happens with that first term. Well, let's put this into some practice first. That might make it a little bit easier. So let's say we have 0, 3, 6, 9, 12, ... So I want to say, how do you get from 0 to 3? Add 3, 3 to 6, add 3, 6 to 9, add 3. You guys get the theme? Okay. So first I'm going to write a recursive formula. Okay. And with our recursive, it's going to be a sub n equals a sub n minus 1, and it's going to be plus 3, and then our first term counts as 0. Okay? If we were to write an explicit, it would say a sub n equals 0, because that's our first term, plus our common difference, times n minus 1. Now, you can leave it like that, but really most mathematicians actually factor it out, so I want to show you how that's going to look. So if we were to do that, we would keep the a sub n equals 0 plus, and now we're going to distribute that 3 to all of that. So 3 times n is 3n, 3 times 1 is 3. I'm going to keep that. Now this is the part that always gets students, so be very careful. We have to combine like terms. So when we do that, you really get a sub n equals negative 3 plus 3n, because 0 minus 3 is a negative 3. Okay, so just be careful. But the cool thing about this, now that we have this formula, I can say, well, I want to know what happens when we get to the 20th term. What is the 20th term? And so I can use the explicit formula. And so in place of n, I'm going to put in 20. So it's going to be a sub 20 equals negative 3 plus 3 times 20. And so it ends up being negative 3 plus 60, because 2 times 3 is 6. Add the 0, so it's 60. And so we have to subtract, and we will get 57. So the 20th term of our sequence is 57. Technically, just bear with me, guys. So since this is the 20th term, I could then put it into the recursive formula and find the 21st term. But since you guys are so smart, I'm not worried about that, because you understand that you would just take this and add 3. It's just another way to do it. Okay? And this is all we're doing. Let me pull up another screen so I can show you how we go back and forth, though. This part can be kind of confusing. So, I'm going to say R for recursive, and we're going to have a sub n equals a sub n minus 1 plus our difference, and I'm going to say here's our explicit. A sub n equals a sub 1 plus d times n minus 1. This is just to kind of help us remember here are our formulas. Don't forget this one, we need to have a sub 1 equals whatever that is. So, if we have our recursive formula, and we know that we have a difference of 5, and our first term is 10, okay? To write this in explicit, I'm just going to pull the information from that and put into the explicit. So I need this part, and I'm going to need this part. So what we're going to do is it's going to be a sub n, that's fine, but in place of a sub 1, I'm going to put in what it is, which is 10, plus our common difference, which is positive 5 in this case, n minus 1. And I'm just going to distribute that 5. Remember, we're just going to distribute it to kind of help us out and streamline our formula a little bit, because you might see it this way, you might see it where you actually have to distribute it. So a sub n equals 10 plus 5n minus 5. And now I want to combine like terms. We have a positive 10 and a negative 5. So a sub n equals 5 plus 5n. And this would be going from the recursive to the explicit formula. Okay? So all you're really doing is just replacing it. Now, let's go from explicit to recursive. So let me just move that down. I'm going to pull up a new ink color. So, our explicit formula is going to say a sub n equals 2 plus, let's see, negative 3n. Let's say they give it to us this way, which remember is just the combined form. So what we're going to do is we need to find that first term. I know everyone says, but what about the 2? That's our first term. No, that's our first term after we combine everything, but that's not our real first term. So to do that, I'm just going to replace n with 1. So 2 plus negative 3 times 1. So the first term of our sequence would be 2 plus negative 3. A sub 1 equals negative 1. So the first term of our sequence is really negative 1. So we're going to use that information. So I want this piece. And we're also going to need this part, because our common difference hasn't changed. Nothing happened to it. It didn't need to be combined with anything. So I'm going to need that in order to write my recursive. So this is my explicit. And I'm going to write my recursive. So it's going to be a sub n, remember, equals a sub n minus 1. I'm doing a plus -3. You could also do a -3. And then all you have to do is say, what's our first term? Pulling that from here, which is a -1. So remember, so now I'm going to make an OR, just for you guys. A sub n equals a sub n minus 1 minus 3. And then everything else follows. Because I know sometimes you guys will ask, but wait, it's a minus, it's a plus. It can be both. Okay? And this is it. This is all you have to do, and all you have to know for the sequences. Check back, and we'll do some more.